Hello, Algebra 1. Today we're looking at 6.3 special products of polynomials and division of polynomials. So we're not going to go very far into dividing, just a little bit. We're going to divide polynomials by a monomial and show you how to do that. And we're also going to look at these patterns. So one of the patterns is the square of a binomial pattern. And I want to stress that you can totally do these without a pattern, but the pattern will save you some time, and it might help you also later when we do, well, I think it will help you. Yeah, it'll help you later when we do factoring and completing a square and things like that. Okay, so use the square of a binomial. I think I'll start down here with showing you how to do this without a pattern. So without a pattern, you're just going to write this twice. X plus 4 times x plus 4. That's the definition of squaring, is you multiply it by itself. And then you can just distribute x squared plus 4x, and then distribute the 4 plus 4x plus 16. And then you can combine like terms in the middle, and you'll get x squared plus 8x plus 16, and you're done. But somebody noticed when they've done it, when they did a few of these, that there's a pattern you can follow. And the pattern, I'm going to write it up here. The pattern is this. If you have a binomial squared, your result is going to be the front term squared, the back term squared, and in the middle, you're going to multiply the two terms together and double it. So check this out. X squared, 4 squared, multiply these together, you get 4x, double it, you get 8x. It's a pattern to do. Now, once you get the pattern down, it is quicker, but as you're learning the pattern, it may take a while to kind of, you know, stick. All right, so on this next one, I'm going to use the pattern. 3x squared is going to be 9x squared. Negative 2 squared is 4. In the middle, we multiply these together, get negative 6x. Double it, we get negative 12x. Just like that, my friends, just like that. Okay, so in Algebra 2, you're going to learn something called completing the square, where you're actually going to get your polynomial to look something like this, and then you're immediately going to write it as a binomial squared. So that's why it's kind of important to learn this pattern, because a lot of you are going to see it later on, just in reverse. All right, so let's move on, I suppose, to the other pattern. And I'm going to start out just by doing it by distributing, and then we'll talk about what the pattern is. So t times t is t squared, t times negative 5t. Then we switch to the 5 and distribute it. 5t, negative 25. But check this out, when you combine like terms, the 5t's go away. And you're left with a binomial, which is kind of interesting. So what's the pattern? Well, these are actually called conjugates. I'll write that word down. You don't have to memorize it or anything, but they're called conjugates. So when you have the same binomial, but one's addition and one's subtraction, then what happens when you distribute is the middle terms eliminate. They're opposites, they go away. and you're just left with the front and the back. So let's go up here and write that pattern down as kind of a formula. So if you have conjugates, you have A minus B and A plus B. Then the middle stuff you don't have to worry about. You're going to just have the front in the front and the back times the back. And that's all there is to it. So let's try this out. We've got conjugates. They're the same except one's plus, one's minus. Doesn't matter which one's first yeah. Okay, so the middle's going to go away, so we just do front times front. Back times back. And we are done. Okay, so on your homework, please try to get used to that pattern and try it out. Yeah, try it out till you have it memorized. And then if you get to a test or a quiz and you forget, just revert back to distributing, and you'll probably remember it once you distribute it out. Okay, the other thing we're going to look at today is dividing by a monomial. And what's cool about this is just like how you would distribute if you were multiplying, you can also distribute division. So here's what we're going to do. Since this whole polynomial is divided by 2x, I'm going to divide every little thing, every term, by 2x. Divide every term by 2x. That's going to give me 4, and then I subtract the exponents, x to the third. Negative, I guess 1 I could say. I don't have to write the 1, but negative for sure. And then subtract the exponents, x squared. Plus 5x, and then 2x divided by 2x, it's 1. 2x goes into 2x one time, it's 1, and that's how it's done. That's how division goes. You distribute the division. Distribute the division. All right, so let's try a couple more. Divided by 3y, divided by 3y, divided by 3y. All right, so I've divided it to everything. I've distributed the division to everything, so I'll cross that out. And then we get y to the 5th. Ooh, we get a fraction, 2/3. Y to the 3rd, another fraction, 5/3. Y minus 2. And on this last one, it's just written another way, but do you see how all of this is being divided by 3xy? You're going to distribute it. You're going to divide the first term by 3xy. The second term by 3xy. And finally, the third term by 3xy. And looks like we get a fraction again, 2/3. It's like 0.6 repeating, so we'll just leave it as a fraction, 2/3. The x's divide, leaving 2x squared behind. The y's divide, leaving a y behind. The 3's divide out, they're gone, or we could put a 1 if we wanted. We've got an x and a y left over. And then back here, 6 and 3 is 2, and the x's and y's divide out. So there you have it. Thank you for watching.